Today we are going to discuss the paper, 28th January paper. Okay, the first one. Which one of the following compounds of group 14 elements is not known? So which is not able to be formed here in this case? So the silicon what now here is having what now 6 chlorines around it. So the silicon with 6 chlorines not possible, but SiF6, SiF6 minus 2 is possible. SiF6 minus 2 is possible, but this SiCl6 is not possible because the interaction between Cl minus lone pairs, the lone pairs of Cl minus and Si plus 4. So between Si plus 4 and the lone pair of this Cl minus, the interaction will be weak. So a weak interaction will be there. So weak interaction between what and what? Between the lone pairs of Cl minus and Si plus 4 ion. Because of this weak interaction, what happens? The SiCl6 is not possible to be formed. Remaining will form here. GeCl6 will form, SnOH second 6 will form, SiF6 is possible to be formed. Next, the element that shows greater ability to form pi bonds between p orbital and p orbital. So p pi, multiple bonds means double bonds and triple bonds. So the double bonds and triple bonds between two p orbitals. The pi bond formation will be done by carbon. Carbon can easily form what? The pi bond between p orbitals and p orbitals. Next, compound A is used as strong oxidizing agent. So what you have to understand first thing, strong oxidizing agent here undergoes what now? It undergoes which reaction? Tell me.
Production.
Undergoes reduction. Undergoes reduction easily, right? Undergoes reduction very easily. That point is. And also they gave that hint amphoteric in nature. The compound is amphoteric in nature. So which oxides are amphoteric in nature? I told you lead oxides and tin oxides. The tin and lead oxides are amphoteric in nature. So the compound should undergo reduction and also the compound should be amphoteric in nature. Amphoteric in nature meaning what? It will react with both acids and bases. Okay, so here it is the part of lead storage battery. So this one actually we study in electrochemistry. In electrochemistry of class 12, we'll discuss about this lead storage battery. But they gave hint about what now your amphoteric nature we understood, and strong oxidizing agent means it must undergo reduction we understood. Suppose if you take Pb plus 4, Pb plus 4. Pb plus 4 is less stable or more stable? It is less stable.
Less
Pb,
stable.
Pb plus 2 is more stable. Pb plus 2 is more stable due to inert pair effect. That's why the Pb plus 4 must be converted into what? Pb plus 2. And this reaction is what now here? Oxidation. So the Pb plus 4 ion undergoes for oxidation to convert into Pb plus 2. So in this way we can understand that PbO2. In this PbO2, oxygen each one minus 2 into 2 minus 4, then Pb has plus 4 here. So like this, you can understand that PbO2 should be the answer. A is what we have PbO2. Next, the basic structural unit. The basic unit of feldspar, zeolites, mica, asbestos. So these all are what now here? Silicates, right? Zeolite, feldspar, mica, all these are what now? Silicates. So these silicates majorly contain what now here? What is the basic unit of that? SiO4 minus 2. Okay. So in orthosilicates, no oxygen will be shared. In pyrosilicates, one oxygen will be shared between the two SiO4 units. Like this, SiO4 minus 4 is what? The basic structural unit of silicates. So these all are examples of what now? Silicates. These are examples of silicates. That's why silicates, the general unit is what now? SiO4 minus. Next. Match the items in column 1 with column 2. Now silica gel. Silica gel. So silica gel is what now here? Hygroscopic in nature. Is what? Hygroscopic. Hygroscopic in nature. Meaning what? It will absorb the water. Hygroscopic in nature. So it will be acting as what drying agent. Will act as what of here? Drying agent. Okay. Next, silicon. Silicon is what now generally used as transistor. Semiconductor, right? All na? Semiconductor. So transistors and diodes. Transistors and diodes generally will be used as what semiconductor. So here now first one, silicon is first. And silicone, silicone, it will be used as what now here? Sealant. Sealant means what now? To not allow the oil to be leaked. Suppose if you take car engine. In car engine oil will be there na? To not allow the oil to be leaked, there will be some seal. The sealant will be there. So silicone will be used as what now? Some sealants, which will prevent what leakage, which will prevent the leakage of the oil. So silicones will be generally used as what? Sealants. So it is what now here fourth. Next, silicates. Zeolite is there now. The zeolite will be used in what now? Generally, it will be used in what? Ion exchange method. Zeolites are used in ion exchange method. Means to convert the hard water into soft water. To convert the hard water into soft water, we use what? Zeolites. So zeolite is an example of what? Silicate. So the first option is matched. Next, among the following substituted silane, generally silane means what? SiH4. This is silane here actually. So silane means this one. Now in this substituted silanes meaning what? In place of hydrogen atom, the methyl groups and chlorine atoms will be substituted. So among the following substituted silanes, which one will give rise to cross-linked silicone? Which will give rise to what here? Which will give rise to cross-linked silicone polymer on hydrolysis. On interaction with water, which of these following options will give cross-linked silicone? Not straight chain. Not straight chain, but cross-linked should be formed here. So option is what now here? Alkyl trichlorosilane. Okay, example we take what now for this? For this we take CH3 methyl SiCl3. What we read this one? Methyl trichlorosilane. Methyl trichlorosilane is used as what now here? The material which is used to produce what? Cross-linked silicone. So the cross-linked silicone polymers will be made by using what? Alkyl trichlorosilane. So this one. Next. And tell me out of the four options, which will be used to block the increase in the length of the silicone polymer? To block the length of chain.
R3SiCl.
R3SiCl means CH3 taken twice, SiCl will be used to block. But here to get the cross-linked, we use what? RSiCl. RSiCl. Next. The incorrect there. Incorrect statement regarding the structure of C60. C60 means Buckminster fullerene, buckyball. So they gave here, it contains 12 six-membered rings. They gave here. So here they said that 12 hexagons. 12 hexagons, is it right or wrong? It is wrong.
Wrong.
Actually, how many pentagons should be there? 12 pentagons should be there. 12 pentagons is right. 12 pentagons is right, but here 12 hexagons is wrong. That's why the first option is incorrect. Next, the six-membered rings means hexagons are fused to both six-membered and also five-membered rings. Means what? What does it mean here? This point, the hexagon will fuse with what? Pentagon. Hexagon will be fused with what? Pentagon, and also with one more hexagon, like this. So if you take one hexagon, the hexagon may combine with the hexagon and also with the pentagon. Okay, so it is what the point is given. This point is correct here. And each carbon atom forms 3 sigma bonds. Each carbon atom forms what? 3 sigma bonds. So when carbon forms 3 sigma bonds, that is which hybrid orbital? sp2. So that carbon is called sp2 carbon. So the carbon is sp2 hybridized in C60. That's why we have to say what now here? Each carbon atom forms 3 sigma bonds. 3 sigma bonds means it should be sp2 carbon. So it is what now here? sp2 carbon, they gave indirectly. So it is correct. Correction. Next, the 5-membered rings means pentagon are fused only to 6-membered rings. It is correct. The 5-membered ring is fused, is combined with only hexagon. That's all. Pentagon does not combine with pentagon again. Pentagon only combines with the hexagon, but hexagon fuses with the hexagon as well as pentagon. So the 2, 3, 4 options are correct, and first option is incorrect. What is the correct statement of first option? Tell me, anyone. What is the first option correct statement? P60 contains 12 5-membered rings and 20 hexagons, 20 6-membered rings. That is correct statement. But it is given what now? Wrong. 38. The carbon-carbon single bonded. The carbon-carbon single bonded is maximum in what? So graphite, how much it is? 1.42.
1.42.
And in the C60, C70, it will be
1.4.
Here also 1.4 angstrom. And there in diamond, how much? 1.54. In which case maximum is the diamond. Next, the percentage of lead in lead pencil. Generally, lead pencils are made up of what? Graphite.
Graphite and clay.
So 100% graphite only is there. Yes, remember, 100% what is there? Graphite only is there. 100% graphite here. Okay, there is no lead in this. Lead will be 0%. Okay, that's why that's 0%. Next, which of the following does not exist? Okay, now SiCl4. What is the oxidation state of silicon? Si plus 4. So Si plus 4 stable or unstable? Stable. And in CF4, carbon with the plus 4 is there. Okay, the topper elements of the group 14 will be exhibiting what? Plus 4 stable. Plus 4 stable. And here CCl4 also P plus 4. And in lead iodide, Pb plus 4 is there. So Pb plus 4 is not stable. Is not stable because of inert pair effect. Because of inert pair effect, Pb plus 4 does not exist. So PbI4 is unstable because the large sized iodine, cannot be held by what? Lead. Pb plus 4 means with more positive charge now. If any ion has more positive charge, its size should be very small. When size of lead plus 4 is very small, the small sized lead plus 4 ion cannot hold the large sized 4 iodine atoms. So because of 4 iodine atoms, large sized, it cannot be formed. Which of the following carbohydrates develop blue color on treatment with the iodine solution? So I told you that starch. Okay, starch gives for blue color generally. This starch is made up of 2 components, na? Amylose and amylopectin. Amylose and amylopectin. So these 2 will be there. So amylose is one component of starch. Amylopectin is one component of starch. And this amylopectin is what? Branched. Is what now here? Cross-linked means branched. Branched chains will be presented. And glycogen is there, na? Animal starch. That glycogen animal starch resembles what now? Amylopectin. The glycogen also is branched, which resembles what? Amylopectin of the starch. And here amylose will be the part of starch. Is a part of starch, which will give blue color on reacting with what? Iodine solution. So amylose also. And remaining glucose, sucrose, fructose, they will not be. Here glucose will convert what now? Tolerance reagent into silver metal. And failing solution will be changed into red precipitate by glucose. That you know. Next, lactose on hydrolysis gives glucose and galactose. It is correct. Sucrose will be giving what? Sucrose will give what? Glucose and fructose. Glucose and fructose. And lactose will be giving glucose and galactose. Okay. And one more, maltose is there. Maltose. Maltose on hydrolysis will produce what? Only glucose.
2 molecules of glucose.
Sucrose will be giving glucose plus fructose, And lactose, milk sugar. Milk sugar will be giving what? Glucose and galactose. Next, the second assertion is given this one, and the reason is given that lactose is an example of disaccharide. So this statement is correct. The first statement also is correct. But as it is disaccharide, it is giving glucose and galactose. No. Disaccharide may be giving glucose fructose. Disaccharide may be giving only 2 glucose molecules. Okay. Or disaccharide may be giving any 2 monosaccharides. But here need not to always give glucose and galactose. So both statements are correct, but the reason is not correct explanation for assertion. So both assertion and reason are true, and R is reason is not the correct explanation for it. Next, the correct statement among the following. So they have to correct here. First one is given: sucrose is reducing sugar. Wrong. Why? It is non-reducing sugar. So this is what? Non-reducing sugar, but they give reducing sugar, so it is wrong. Next, 2. There are 2 alpha D glucose units. 2 alpha D glucose units in maltose are linked by 1,4 linkage. This linkage is called what? Glycosidic linkage. 1,4 glycosidic linkage. So 1,4 glycosidic linkage is present in what? Maltose. So I told you maltose will give how many glucose units? 2. Which type of glucose? Alpha D glucose units. And both alpha D glucose will be joined with each other by what now? First carbon of one glucose and fourth carbon of another glucose will be linked. So this is correct statement. And next one is given: beta D glucose and beta D fructose units are linked in lactose therefore. Actually, this will be done in what now? Sucrose, glucose and fructose. Okay, actually alpha glucose and beta fructose will be linked there in the sucrose. But here they give lactose, they give. But in lactose, actually what will be there? Glucose and galactose will be there. Fructose will not be there. So it is incorrect. Next, all polysaccharides are reducing non-sugar. No, need not be. Okay, so all polysaccharides are reducing sugar, reducing non-sugars. We cannot. Okay, they may be sometimes non-reducing. So what we are, this point is wrong. So only second option is correct. Next, now what is this molecule? First one, C12H22O11 is what? Sucrose. Okay, it is what now? Cane sugar. What is cane sugar? Sucrose. So this sucrose undergoing hydrolysis in presence of one enzyme. So some enzyme A is given. So one enzyme A, that is what? Invertase. Invertase, we can say, or we say sucrase. Okay, invertase or sucrase, one special enzyme, it will convert what now here? Sucrose into what? Glucose and fructose. Actually, in the topic what now here? Biomolecules, we study all these things. Okay, so the enzyme invertase or sucrase will convert what now here? The sucrose into glucose molecules. 2 glucose molecules are produced here. Okay, glucose and fructose will be formed. Glucose will be what? One glucose and one fructose will be formed. Again, this glucose now next. In second step, the glucose will be converted into ethyl alcohol and CO2. It is manufacture of what? Ethyl alcohol. The manufacture of ethyl alcohol we use what? Glucose. Actually, this solution name is what now? Molasses. Molasses is obtained in sugar industry. Okay, in the sugar industry, molasses will be obtained. The molasses will be used here to produce what? Ethyl alcohol. Molasses is the byproduct of sugar industry. Okay, so in that sucrose first converts into glucose and fructose. Again, glucose will be converted into ethyl alcohol and CO2 gas. Okay, now this enzyme, the enzyme B is what now? Zymase. ZYMase. So these 2 enzymes, remember. So sucrase is also called invertase. Invertase or sucrase, both same. So invertase converts what? Sucrose into Glucose plus fructose. And glucose will be converted into ethyl alcohol and CO2 in the presence of diamazine. So, invertase and diamazine. Next. So, it is proteins out of syllabus. And here it is also now nucleic acids. Okay. Proteins. Okay. These are all things we didn't have, means we don't have syllabus in this week now. So, proteins and all now, there are only carbohydrates from biomolecules we have. Up to 44 only. Next. Hormones not there. And DNA, nucleic acid is not there, vitamins not there. Do you know this bit? At least vitamin B6 is known as what? Pyridoxine. Pyridoxine or pyridoxine kids either. Okay, that you must be learned in class 10. Okay. Next, then what is the question? Which coordinated number? CN means what? Coordination number. Which coordination numbered complexes are formed by EDTA? So we study this lesson, this one in coordination complex. In class 11, class 12, there is one lesson called coordination complex. Okay, the coordination complex lesson we study about this. So this EDTA is one type of ligand. One type of ligand. These are all types of ligands we study in coordination chemistry. That is in class 12. Okay, so remember that this EDTA will be always exhibiting what now here? Coordination number of 6. Remember.
Excuse me, sir.
The coordination number 6 will be shown by the complexes in which EDTA is acting as what? Ligand. Okay. It is ethylene diamine tetraacetic acid. The full form and all everything we'll study in another lesson, coordination chemistry. Okay.
Sir, if we were going to study this in 12th standard, then how are we supposed to answer this right now?
Yeah, that's what I'm telling you. All the out of syllabus is given. That proteins and all also from what? Class 12. The paper setter has taken what only the total lesson of biomolecules has taken. Whoever has set the paper.
So then we should have flea marks.
Yeah, that all ad score must be given. Okay, we'll check it now. I will mail the central office. Okay, we'll discuss about that. And I'll see next one's here. So for a good quality cement, the ratio of calcium oxide to other oxides. So calcium oxide to other oxides must be 2:1 ratio. 2:1 ratio should be present, 2/1. That is 2. Next, the value of N in the molecular formula Be taken in Al2 Si6OH. It is beryl. The compound name is what now here? Beryl. So what is the beryllium number here? 3. Be3 should be present. Be3 should be present. Beryl formula. Next, how many of the following will turn moistness with water? Red litmus, blue. Okay, now red color will be changed into what? Blue. The red litmus will change into blue color and finally white color. So in this reaction now here, what we have to take is that this process will be first converting red litmus into blue and then finally into white will be done by superoxides, peroxides, superoxides, peroxides, and ozonides. Remember this three names. Ozonides, superoxides, peroxides. These will convert the red litmus into blue and finally into white. So in this now here, KO3 is called what now? Potassium ozonide. Potassium ozonide. KO3 is what? Potassium ozonide. And RbO2. RbO2 is what now here? Is it superoxide or peroxide? It is superoxide. Superoxide. In the superoxide, what is there? O2 minus 1 is there. O2. Rb plus 1, na? Rubidium, first state group element. Rb plus 1, then O2 minus 1. So this is what now superoxide. And cesium peroxide is one. CS2O2, like Na2O2. It is what superoxide or peroxide? It is peroxide. So peroxide, rubidium superoxide, potassium ozonide. And next, barium peroxide is here. BaO is what? Barium peroxide. So barium peroxide, cesium peroxide, rubidium superoxide, and potassium ozonide. These all will convert the moist red litmus paper into blue and finally into white. Remember this bit. Remaining what now? Lithium oxide, monoxide, beryllium monoxide, magnesium oxide, strontium oxide. So now how many total here? 4. 1, 2, 3, 4. Next now, Na2B4O7, 10H2. What is here? 10H2. It is what now? Borax. This borax. So when borax is heated at low temperature, at lower temperature, suppose if you heat at high temperature, what happens directly? At high temperature, directly it will convert into Na2, B4, O7. If they don't give any temperature and if they say high temperature or heating simply, directly anhydrous Na2B4O7 will form without water. Here 60 degrees Celsius, what happens is that first it will be changed into what now here? 5H2. How many H2 will form first? 5H2 will be forming here. Okay. So after that here, Z is what now here? 0. Like this last two will form. So here only Na2B4O7 will form. Only Na2B4O7 means what? 0H2 will be there. And Z will be 0 here. No water molecule. Here Y will be 5 and X will be 10. Okay. So here 10 minus 5. Okay. Plus what? 0. That is 5. So 5 will be what now here? Next. When glucose is reacted with bromine water. Now bromine water is mild oxidizing agent, strong oxidizing agent, mild oxidizing agent. Now in presence of mild oxidizing agent, bromine water, what will be forming? The glucose C6H12O6 will change into what now? It will form COOH bond CHOH taken 4 bond CH2OH. Do you remember this? What is the name of this? Gluconic acid or saccharic acid? Is it gluconic acid or saccharic acid? It is gluconic acid. In gluconic acid, how many COOH groups available? Only one. So they get that. So when glucose is reacted with bromine water, mild oxidizing agent, the major product is X some compound. In that small X number of carboxylic acid groups are present. Means COOH groups are present. So how many COOH groups present here? Only one. Suppose if you take what now here? HNO3. Glucose in the presence of what now here? HNO3. HNO3 means what? Strong oxidizing agent. In presence of strong oxidizing agent, what happens? The top COOH will be there and the middle CHOH taken 4. And at the bottom also what will be forming? COOH. So how many COOH groups in this? 2 there. It will be called what now? Saccharic. Saccharic acid. So saccharic acid has how many COOH? 2. But gluconic acid has how many? 1. So answer is what here? 1. Only one COOH group is present. Next, in amino acid. So this amino acid is not included. Next, pyron. Pyron means what? How many carbons and how many oxygens? It is 6-membered ring or 5-membered ring, pyron?
6-membered.
6-membered ring. In this, how many carbons? 1, 2, 3, 4, 5 carbons will be there. And 1 oxygen will be present. And here 1 double bond, here 1 double bond. This is pyron. And the next one here in pyron, number of carbon atoms, how many? 5. And number of oxygen atoms, how many? 1. So what is the value of X plus Y? It will be what now here? 5 plus 1. Next, number of 6-membered rings. number of 6-membered rings present in a steroid. This is not the issue. Okay. Next, in the following, how many acidic amino acids? So now these are from carbohydrates and group proteins.